So we're going to continue our exploration of sequences today and focus on geometric sequences um, and look at explicit sequences. And when we look at explicit sequences, what that means is that we're able to like jump to a specific term. It's going to look like a specific type of function. So here we have this sequence that a sub n equals 3 times 2 raised to the n minus 1. So let's start by finding the first 5 terms. To find a sub 1 when we're given an explicit rule, okay? And notice that this explicit rule just has this n. We don't have any a's in the rule like we did for the recursive. So a sub 1 means that we're going to put 1 in for n. And if I put 1 in for n, what's the exponent going to be up there? 0, okay? And anything to the 0 power is 1. So that's going to be 3 times 1, which would give us 3. A sub 2 is we're going to take 3 times 2 to the 2 minus 1. So that means our exponent is 1. So we're going to take 3 times 2, which is 6. A sub 3 would be 3 times 2. We're going to put 3 in here to the 3 minus 1. So that's going to be 2 squared. So that's going to be 3 times 4, which is 12. A sub 4 is 3 times 2 to the 4 minus 1, which is 3. So 2 cubed is 8. 3 times 8 is 24. And maybe we established a pattern, but even so, let's just find one more. A sub 5, we have 3 times 2 to the 5 minus 1, which is 4. 2 to the 4th is 16, and then 3 times 16 is 48. So those are our first 5 terms. What pattern do we notice could we use to get from one term to the other? You're doubling, okay? So basically we're multiplying by 2. And when we talked about that idea in as far as the sequence goes, when you're multiplying by something, what type of sequence did we say that was? Yeah, so this is going to be geometric. So let's graph this. We have to go all the way up to 48. So maybe let's go by 5. I'm just labeling every 10. And then again, I should have labeled these the other day. This is our a sub n, and this is our n. And then I'll just go by ones on this axis. And after we have those labeled, it might be easier for us to plot. So we've got 1, 3, a little more than halfway here, 2, 6, just above 5, 3, 12, 4, 24, just below 25, and 5, 48. Ooh, you guys, this isn't looking linear. Is that a problem? No. And again, we're not going to connect. In a sequence. And before we answer what family this is, because I understand that it might look like a couple different ones, I also want you to look at the equation itself. Based on the equation that we used in this graph, what family of function does this appear to be? Exponential. So what we're going to look at today is that just like the arithmetic sequences were linear, the geometric sequences are going to be exponential. And our rule for our geometric sequence is going to basically follow that same thing. The nth term of a geometric sequence with a first term a sub 1 and common ratio r is given by a sub n equals a sub 1 times r to the n minus 1. This is what we're going to use for the geometric sequence. Yesterday for arithmetic, that's when we used this idea of a sub n equals d times n plus a sub 0 for arithmetic. So for geometric, when there's a common ratio instead, we'll use this. So a little example, it says the nth term of a geometric sequence with the first term of 5. That's telling me that a sub 1 is 5. And common ratio 4, that means that r is 4, would be given by this equation. We'd say a sub n equals. The nice thing about the geometric is that a sub 1 is in there, okay? We actually see a sub 1. In the arithmetic, we saw a sub 0 and not a sub 1 in the rule. But here we're actually going to use that a sub 1, which is 5, times 4 raised to the n minus 1. And you're done. Like that's it. Okay. I do want to take a second, however, and compare the previous exponential form, which was y equals a times b to the x, and this form for an explicit geometric sequence, a sub n equals a sub 1 times r to the n minus 1. So again, when we talked yesterday about arithmetic, we talked about the idea of the linear equation and how that was just like y equals mx plus b. This is a little bit different because in our general exponential equation, we have x here, but in our geometric sequence, we have n minus 1 instead. So one thing is that we see is that the previous exponential form just had b to the x. And so what that means is that a was the y-intercept, and that occurs when x equals 0. Okay? So the previous exponential form just had b to the x, and a was the y-intercept when x equals 0. But this sequence form has r to the n minus 1. And so what that means is that our a sub 1 must be used to make our exponent 0. And when our exponent is 0, doesn't this turn into 1? And then this is kind of like what we're left with. So the geometric sequence has r to the n minus 1. So what that means is that we use a sub 1, we use our first term to make sure that our exponent is 0. So here, that's our y-intercept. So that would be like an a sub 0 in our exponential form here. But just traditionally, in this geometric form, we have this a sub 1 times r to the n minus 1, but they're easy to write. So this says to write a rule for the nth term. Write a rule for the nth term of the sequence, 5, 2, 0.8, 0.32, etc. And then after that, we'll find a sub 8. So if we wanted to do that, we need to find two things. We need to find a sub 1. And do we know a sub 1 by looking at this sequence? Of course we do. It's just 5, right? So this is our a sub 1. And then the second thing we need is r. And if we're not sure what r is, and we touched on this when we went over the first day's homework, if we're not sure what r is, we can always divide, remember, our new term divided by our previous term. So if it's not obvious to you what it is, then just do that. So we're going to take 2 over 5, which is fine. You could turn it into 0.4 if you wanted. It doesn't matter to me. Okay. And then if you wanted to double check, like if you weren't sure, then you can just see if that works for the other ones. So see, like, all right, if I multiply this by, do you want to use 0.4 instead of 2/5? Okay. If you multiply this by 0.4, we get that's going to be 2. Well, let's think about, we don't even really need to do much. If we multiply 2 by 0.4, isn't that going to give us 0.8? If I multiply 0.8 by 0.4, isn't that going to give me 0.32? So that kind of confirms that our R value is going to be 0.4. And so then we can use that to write our rule. A sub n equals 5 times 0.4, or you could use 2/5 to the n minus 1. So these basic ones are nice. We don't have a ton of stuff to do. We just need a sub 1, r, and we're done. And then we can find a sub 8 very easily in this explicit form. How do you think we would find a sub 8? Put in 8. Good. So we're going to have 5 times 0.4. And so what exponent would we have up there? 7. Okay. So this is why I thought maybe we could, okay. So we can get our calculators out and divide or put that in. So we have 50. Oh, it's not letting me do that with this screen. So we're going to take 50 times 0.4 to the 7th power. Oh my gosh. Oh my gosh, it's 5. What is my issue? I need to go home. Everyone on the video is like, this lady is nuts. All right. And so we get this value that a sub 8 equals 0.008192. You guys have that? This is a place where it's not really appropriate to round. Okay, so we're going to want to say a sub 8 equals 0.008192. Okay, unless it asks you to round, give that exact answer, please. Okay. Okay. So, okay. So that's easy when we know both a sub 1 and r. If you do not know both a sub 1 and r, then what we can do is substitute the given information into the formula. We'll find a sub 1 and then write our formula appropriately. So if we look here, it says one term of a geometric sequence is a sub 4 equals 12. The common ratio is r equals 2. Let's write a rule for the nth term. Well, this right here is really going to be like our n. This 4 is going to be like our n. And the 12 is going to be like our a sub n. So again, let's think about this formula. A sub n equals A sub 1 times r to the n minus 1. And let's put those values in. In for A sub n, I'm going to put the value of the term, which is 12. I don't know what A sub 1 is in this problem. They didn't tell me. It tells me my r is 2. And I'm going to put 4 in place of n. And you can just write 3, that's fine. I'm just being dramatic, okay? To make sure we understand where we're going here. So I have 12 equals A sub 1 times 2 cubed. Okay? And what is 2 cubed? 8. How would I need to isolate the A sub 1? Divide by 8, okay? So I have that A sub 1 equals 12 over 8. I can reduce that to 3/2. And now I have what's necessary to write my rule. My A sub n equals A sub 1, which is 3/2, times r, which is 2, to the n minus 1. Oh, you know what else? Sometimes people like to cancel these. That's a horrid plan. Why is that a bad idea? It's illegal. Because what do you have to do as far as order of operations? What has to come first? The exponents, okay? So even like, so don't be tempted to multiply these two things together. You can't, it's illegal because of the order of operations, okay? But this right here is your rule, okay? All right, so what I'd like you guys to do real quick is to do these two you try questions. Do you try A, 1 and 2, 1A and B. So do you try 1 and 2 based on what we've talked about so far, okay? So now that we've had a few minutes to look, let's look at the you try questions. Here we were able to identify A sub 1 as 4, and what was your R? What was your R? Your R value is 5. So what you can do is then just put that in here. So this is how your rules for the geometric sequences need to look like. You need a number for A sub 1, you need a number for R, and then that's raised to the n minus 1. Now that we have that rule, we can find A sub 7. If I put 7 in for n, that means that we're going to have an exponent of 6. So A sub 7 is 62,500. Any clarifications on you try 1, A or B? Okay. All right. Here's what happens in you try 2. We know that our common ratio is R, and we know that then 3 is going to be in for n, and -2 is our A sub n. And I had a couple people that just stopped here, okay? Is that a rule that looks like this, what happened in number 1? No, okay? So this is not a rule, this is your setup, and because of this setup, you're able to find your A sub 1, all right? So to find the A sub 1, we're gonna do 3 squared, which many of us, we now know is 9, okay? So I have that -2 equals A sub 1 times 9. So to isolate A sub 1, what would you need to do? Divide by 9, and then we have that A sub 1 equals -2/9. Is that a rule? No. So then what we do is we put that back into the rule where we always have an A sub 1 value and always have an R value. Does that make sense? Okay. So you want to make sure that your rule includes both A sub 1 and R. All right. So in all the questions that we've dealt with so far, they've told us what R is, but what if we don't know R? If we don't know R, and we are given 2 terms, I'm going to call them A sub m and A sub n, we can write an equation to help us find R. I want you to think about this formula, A sub n equals A sub 1 times R to the n minus 1. Do you guys see that, like, this is n, and this is n, and this is 1, and this is 1? okay? So let's say that instead we didn't know a sub 1, but let's say that we know some random other term, a sub m. What we can do is we can say, all right, now instead of r to the n minus 1, what do you think our new exponent could be? So let's look at this relationship here. N is still, a sub n is still a sub n. A sub 1 has changed to a sub m. So then what else do you think might change? So yeah, we're going to turn this into n minus m instead. So what happens is that we can then just kind of subtract the subscripts for our r value. And so this is what we're going to use to help if we don't know r. So let's try that in example 3. It says two terms of a geometric sequence are a sub 3 equals 48 and a sub 6 equals 3072. Let's find a rule for the nth term, okay? When we talk about a sub n, one thing I'll say here is that a sub n is I'll say the later term, meaning that it's going to happen farther down. So basically that means that your n, make sure that your n is bigger than your m. That'll help. Okay. So in this case, we're going to say that do you guys see that this 6 is bigger than the 3? So that means that we're going to use this as our n. And then we're going to use this as our a sub n. Then by default, this 3 is going to be our m, and the negative 48 is going to be our a sub m. And now let's put them into this idea that a sub n equals a sub m times r to the n minus m. And again, it's really the same formula. It's just that when we know a sub 1, m is 1. So let's put these in. Our a sub n I labeled as 3072. My a sub m I labeled as 48. And then I have r raised to the n minus m. So that's going to be 6 minus 3. Okay. Let's simplify that a little bit. And I can turn that into r to the third. You guys okay with that? Okay. Now, the goal is going to be to find r. What should I do next? Divide by the negative 48. So we're going to divide by negative 48 to isolate the r cubed. And what happens when we divide 3072 by negative 48? Negative 64, okay? Now, how in the heck am I supposed to find r? Cube root, awesome, okay? So let's take the cube root of negative 64. We can take the cube root of negative, okay? It's an odd root, so that's fine. And you can either think about using your power chart, or if you don't remember and you're in the calculator, you can raise negative 64 to what exponent? 1 over 3. Good, 1/3. And what do we get as our r value then? Negative 4. So r is negative 4. Okay. Now remember that our rule is going to be a sub n equals a sub 1 times r to the n minus 1. Don't we still have an issue? We don't know what a sub 1 is. But we have the same kind of information that we had earlier. Can't we use one of these terms to help us? Okay, so we can use one of the terms to help us. Do you guys want to use the 3 negative 48 or the 6 3072? The 3, negative 48. Okay, sorry, the 6, 3072. All right, so let's do that. So what that means in our formula now, though, just to be clear, that like, so now when we're using this in the formula, now the 3 is going to be our n, and our negative 48 is going to be our a sub n in that formula. Do you understand what I'm saying? Like that, even though it was a sub m here, if we're using this in the new formula, in the regular formula, now that's going to be our a sub. So I have that a sub n equals a sub 1 times r to the n minus 1. So I have negative 48 equals a sub 1 times r, which we said was negative 4, to the 3 minus 1, which is going to be squared. Now, what happens when you square negative 4? Positive 16. How will I find a sub 1? Divide. And so now I have that a sub 1 is negative 3. And so then I'll put that in my equation. And remember that in your final equation, a sub 1 equals negative 3 is not a rule for the nth term. The rule for the nth term would be that a sub n equals negative 3, which is a sub 1, times negative 4 to the n minus 1. Okay. So I know I'm trying to label these things as as like n and m and a sub n. So remember, just know that that's fluid, like from one part of the problem to the other. Okay. You guys okay with that? Okay. So I'd like you guys to try 3 now that we've done that one. And I just want us to stop when you get to R, okay? So see what you could do to set up, you try 3, but don't get too far. We're gonna have a conversation with what happens when you get to R. Yeah, we'll go on now. All right, so here's almost what I ended up with. Let's just look at the setup. I had 1024 equals negative 4 times r to the 6 minus 2. I simplified that to 4. I divided, and then I have to take the 4th root. And the 4th root of 256 is 4. But what else is it? There are 2 r values that are possible. Isn't this an even root? Because that was an even root that we were taking, we have to have a plus or minus. So this is, I agree with you, a pain in the butt, because that means that we're going to need to have 2 different possible equations. One when r is positive 4 and one when r is negative 4. It doesn't matter because there was that even amount of spaces between it. We don't know if we were multiplying by a positive or a negative. So let's use this idea of the a sub n equals a sub 1 times r to the n minus 1. And let's first use r equals 4. And I'm going to use the smaller one again, if that's okay. So I'm going to have negative 4 equals a sub n times positive 4 to the 2 minus 1. So that's going to be 4 to the first, which is just 4. Again, you can combine some of these steps if you want. What does that tell me that my a sub 1 is in this problem? Negative 1. So one rule is that a sub n equals negative 1 times 4 to the n minus 1. But there was another possibility. The other possibility is that our r was negative 4. So again, we'll use negative 4 as the output equals a sub 1 times negative 4 to the 2 minus 1. And we can do this simplification. The exponent becomes 1. Again, you can do some of that, combine some of those steps. Negative 4 to the first is negative 4. So what does that make a sub 1 in this case? positive 1. So this is one that has 2 possible answers. We can't tell which one it is. Would I do this to you on a quiz or test situation? No. Okay. But I think it's important to know that those exist. Okay. Last, okay, we all right with that one? Okay, I think there's one like that on the homework. When I pass it, I'll try to remind you which one that is. Yes. Well, that's the thing, is that based on this information, it could be either one. We're not sure. So a way to remedy that is that if we have an odd, see how there's an even number of spaces between them? Whenever there's an even number of spaces between like a sub 2 and a sub 6, or 4 spaces between that, we don't know if we're multiplying by a positive 4 or a negative 4, right? Like, because it could be either one. So that's why we have to say we don't know based on this information. It could be either one of these formulas. So in example 3, however, we were taking the cube root. So the cube root only has one possibility. The cube root only is -4. It can't be positive or -4 because this is an odd root. So because this is an odd root, we only have that one solution. So that's probably what I would give you in a quiz or test situation, is an odd root. So you only have to worry about one R value. Okay, but I want to make sure we know that there are problems that exist where there are 2 possibilities. Okay. All right, last question. It says in 1990, the total box office revenue at U.S. movie theaters was about $42.05 billion. From 1990 to 2003, the total box office revenue increased by about 5.8% per year. And what this is asking us to do is to answer a couple questions. What family of functions best models a situation when a quantity increases or decreases by a percentage? And that is exponential. So when something increases or decreases by a percentage, that means we should use something exponential. So let's write an explicit, okay. It wants us to write an explicit rule. The explicit rule are the ones that we practiced today for the total box office revenue in terms of the year. Well, if it's exponential, doesn't that mean that this is going to imply a geometric sequence? So we can use our rules from today. So what we need for an explicit rule is what A sub 1 is, and A sub 1 represents 1990. Doesn't it tell us that in 1990, it was $45.02 billion, okay? And it says that this is in billions of dollars, so we'll do that. But let's talk about R. The R value, a lot of times people will say, they'll turn 5.8 into a percent, or into a decimal, which is 0.058. But do you see that it increased by that percentage? Which means that it kept its original 100%, which is 1, and added the 5.8%. So if it increased by 5.8%, we want the original 100% and the additional 0.058. So that's going to be 1.058. And that's enough information to write my equation. A sub n equals 45.02 times 1.058 to the n minus 1. Let's really quickly write what a recursive rule would be for this situation. A recursive rule for geometric, remember how we said that we would take the previous term, which is a sub n minus 1, and we multiply it by r, 1.058. But what else did we need for a recursive rule? The first term. Okay. What would we do to find a sub 5? Put it in. So what would our exponent be that we get here? 4. We get 4 as our exponent. And I'll tell you that this is about 56.41. And so that means that in 1994, the box office revenue was about $56.41 billion. All right, so in 1994, the box office revenue was 56.41 billion. And then that would be what that represents in context. So A sub 5 is this is what it was in context. So then notice that we jumped right to the explicit rule to do this. And the reason that we did the explicit rule was because if we did the recursive rule, we would have needed to find all the previous terms. So, and that's because we could jump right to A sub 5 without needing to find our previous terms, like A sub 4, A sub 3, etc. Okay? All right, that's it. Have fun.